We're going to talk about graphing irrational functions. So the things that we're going to really focus on are the square root and the cube root function. I have the basic square root and cube root functions graphed already on our screen. I know they're not on your worksheet, but this is something that we talked about a little bit at the beginning of the year. And also we can just kind of replay it in our minds, and we can substitute values in for x and y into a table and kind of figure out what's happening just by substituting values into a function. If you notice the cube root function, or I'm sorry, let's start with the square root function on the left. It does have a domain and range restriction. That's because in the square root function, I cannot substitute any values in for x that are less than 0 and get a real number out for y. Whereas in the cube root function, as we've talked about a couple times on these videos, I can plug in or substitute in a negative value for x and get values out for y, and those values end up being negative. So these two graphs end up being what they are, um, just based on substituting values in, and that's kind of what they look like. So what we're going to talk about today is just graphing some square roots, graphing some cube roots, and kind of figuring out what's going on. So if we look at this, once again, just a reminder that if I have a function and I have something like the function plus 3 minus 2, what happens is I have a left shift of 3 and a down shift of 2. So those are the types of things that I need to remember from previous units where I was talking about horizontal and vertical shifts, and then some vertical stretching, which we're going to talk about in problem 2. So if I look at problem 1, I have a left shift of 3 and a down shift of 2 from my original graph. So what I'm going to do is I'm going to take this original um, main point of the graph, shift it left 3 and down 2, and then the rest of the function is graphed the way it normally is. So if I look at this function, I'm at -3, -2. Then I go over 1, up 1, over 4, up 2, over 9, up 3 from my original point, and that's kind of what my graph looks like. So if I look at the domain are all the x values that come in. And so if well, that didn't work the way I wanted it to, but if I look at my domain and I kind of scan for a domain, it starts at x equals -3 and moves along. So my domain is from -3 to infinity, and my range, if I scan for a range, that comes from -2 up until infinity. So the range is -2 to infinity. In problem 2, I have a right shift of 4 and a down shift of 3. And then I'm uh, I'm multiplying all these values by 2, so I have a vertical stretch of 2. So I go over 1, up 2, over 4, which is way off my screen, over 4, up 4, and my graph looks something like that. My domain is going to be from 4 to infinity, and my range is from -3 to infinity. Problem 3, I have a left shift of 2 and an up shift of 1. So I'm 2 to the left and then 1 up. And then I have a vertical reflection. So that means that it basically, the normal graph looks like this. It's going to be mirrored on the other side since I have the negative in front. So it's over 1, down 1, over 4, down 2, over 9, down 3. And so that's what my graph looks like. So if you notice, the domain in this case is from -2 to infinity, but the range, if I'm looking at the range, that actually goes from, I don't know why I forgot to put the pen down. That made it look kind of dumb. from negative infinity all the way up until 1. So my range is from negative infinity to 1. So notice that my range includes all of the negative values of y all the way up until positive 1. So what do I notice about the graphs of the square root functions? They have restrictions on domain and range in one direction. Now, if I take a look at 4, 5, and 6, they have the exact same point values, or the exact same shifts. So this one is still left 3, down 2. And there's no vertical stretch, so it's over 1, up 1, and down 1 in both directions. Over 8, up 2, or over 8, down 2 in both directions. So notice that my domain is negative infinity to infinity, and likewise my range is negative infinity to infinity. If I look at this problem, it shifts right 4, down 3, just like the problem above it. It's over 1, well, it's not going to be over 1, up 1, because I have a vertical shift of 2, just like in the last problem. So it'll be over 1, up and down 2, over 2, or I'm sorry, over 8, up and down 4. So it's going to be a little bit stretched from my normal cubic root graph. Once again, though, my domain has no restriction, and neither does my range. In this problem, I have a cube root with a left shift of 2 and an up shift of 1, just like in the problem above it. This is vertically reflected, not shifted, vertically reflected. So that means I go over 1, down 1 to the right, and over 1, up 1 to the left, over 8, up and down 2 in both directions. So it'll look something like that. And once again, my domain has no restrictions. Likewise, my range has no restrictions. So what do I notice about cube root graph? Domain and range have no restrictions. And it doesn't matter what my vertical horizontal shifts or vertical stretches have anything to do with it. So now, given these graphs, write the equation. So this looks like a square root function. My initial point is at negative 3, negative 4. So that means that I have a left shift of 3 and a down shift of 4. And then if I look at some other points that are on the graph, if I go over 9, I'm going up 3. So if I go over 9 and up 3, that fits right in with my square root function, because normally what happens in my normal square root function is I go over 1, so up 1, up 1. If I go to the right 4, I go up 2, and if I go to the right 9, I go up 3, because I'm taking the square root of however much I go up from my initial point. So in this case, if I'm going over 9, up 3, likewise, I went over 1, up 1, I went over 4, up 2, so this just fits in with a square root function. So I'm not having a vertical stretch, so that means I have the square root of x plus 3 minus 4, because I have a left shift of 3, a down shift of 4, and no vertical stretch. Here's a cube function, or a cube root function. It looks like I'm at negative 2, negative 1, so that means, or my middle point is at negative 2, negative 1. So I have a left shift of 2 and a down shift of 1. So that means I have the function is the cube root of x plus 2 minus 1. And then I have to figure out what's happening with my, my point that I have. And so it looks like I went to the right 8, down 4. So normally if I go on a cube root function, so if I'm cube rooting x, if I go up 1, I go up 1, and if I go up 8, I'm going up 2. Well, in this case, when I go up 8 on my graph, I'm actually going down 4. So that means that I'm getting this whole problem multiplied by -2. So because my vertical shift appears to be -2, my vertical stretch, I'm sorry, not shift, my vertical stretch is -2. That means my function is f of x equals -2 times the cube root of x plus 2 minus 1. Left shift 2, down shift 1, vertical stretch 2 with a flip. So that's why it's -2. Describe the shifts that are happening in these problems. It looks like I have a translation or shift left 5 and down 8. And then I have a vertical stretch of 3. And then because I have a negative in front, that means that I have a vertical reflection also. So that means if I sketched a graph, it would be left 5, down 8, and then it looks something like this because it flips and the stretch is 3. So that means that it's going to be a little wider, or I'm sorry, a little stretch vertically than normal. If I'm writing the domain and range of this function, my domain is going to be from -5 to infinity because that value is -5. My range is going to be from -infinity to -8 because the values go from negative values, -infinity, all the way up to this value, which is at -8. Number 10, oh my gosh, it's all these variables. So once again, it's a square root, just like in the last problem. So we're going to have a domain and range restriction. Notice that b is less than 0. So that means if I have the square root of x minus b, that means that since b is less than 0, that means that um, if I made b something like -4, just to mentally conceptualize what's happening, let's say I'll make a something like 3 and I'll make c something like 5, just to conceptualize what's happening. I have 3 times the square root of x plus 4 plus 5, because if I have a negative number subbed in where I have a negative, that's how that's going to look. So that means this has a left shift of 4, an up shift or a up translation of 5, and then a vertical stretch of 3. Now, since those are not actually the values in the problem, I have to replace them with the letters again. So it's a left shift of B, an up shift of C, and a vertical stretch of A. So here is C, here is B, and then my up shift or my up stretch is going to be A. So if I'm writing a domain and range for this problem, my domain is going to be from b to infinity. Remember, I don't have to put negative b because b is a negative number. So b to infinity would be what I put there, and then c to infinity would be what I put for the range.